So today we shall discuss about the MOSFET. What do you mean by MOSFET? What does it stands for? So MOSFET means metal oxide semiconductor field effect transistor. It is a type of FET that has insulated metal oxide layer between its gate and channel. There are two types of MOSFET, depletion type and enhancement type. Both of these MOSFETs are widely used in electronics, integrated and embedded circuits. MOSFET conducts current between the source and drain. The path of current between the source and drain is called a channel. The width of this channel is controlled by the voltage at the gate terminal. So coming into a DMOSFET means a depletion MOSFET. So depletion MOSFET is a type of MOSFET where the channel is constructed during the process of manufacturing. You can see here in the depletion MOSFET there are of two types, that is N channel and P channel. So in the N channel the arrow mark is towards the inwards. In the P channel arrow mark is towards the outward. That is the main difference here. So types of MOSFET, as we discussed, this is how it is being fabricated. You can just look into it. In the N channel D MOSFET, P type will be the substrate, the channel will be N channel, and you can see N type of material, on that the metal oxide layer, on that metal electrode, gate, source and drain. Okay, so coming into a P channel, N type substrate, P channel, P type material, metal oxide layer, metal electrode, gate, source and drain. So main differences, if it is a N channel, the substrate what we use is a P substrate. If it is a P channel, the substrate what we are using is a N type substrate. Coming into a working of depletion MOSFET N channel. In N channel D MOSFET, the source, drain and channel are made during the manufacturing from the N type material upon a P substrate. Channel contains electrons as a charge carrier. There is a metal oxide insulating layer between the gate electrode and the channel and P substrate. You can just look into the diagram here. It is a P substrate N type. When the gate is connected in reverse bias, the negative voltage is applied. The holes from the P substrate will attract towards the gate, depleting it of the electrons and reduces the channel size. At a certain threshold, the MOSFET will stop conduction. Therefore, N channel and D MOSFET have negative threshold voltage. Coming into the working of P channel D MOSFET. So in the P channel D MOSFET, the source, drain and channel are made up of P type material upon a N type substrate. P channel has holes as the charge carrier. Therefore, to reduce the channel width or to attract the electron from the N substrate, P channel MOSFET is applied with positive gate voltage VGS. So when you give VGS, when the positive voltage VGS is applied to P channel D MOSFET, the positive voltage attracts the electrons from the substrate to depletion the channel of holes, thus eliminating the channel as well as the current flow. Therefore, P channel D MOSFET have a positive threshold voltage. The basic MOSFET operation. In a depletion type MOSFET, it can be operated in two modes, depletion mode and enhancement mode. So when VGS is 0, ID is equal to IDSS. When VGS is lesser than 0, ID is lesser than IDSS. These are the two conditions. So this is a diagram. You can see VDS versus ID plot. When it is a plot of different values of VGS, So you can see enhancement as well as depletion mode here. Okay, D-type MOSFET in depletion mode. So E-MOSFET means enhancement MOSFET. Enhancement MOSFET is a type of MOSFET where no channel constructed during its fabrication, but it is induced in the substrate using the gate voltage. E-MOSFET does not conduct when there is no gate voltage. Therefore, E-MOSFET is also known as normally off transistor. So type of enhancement MOSFET. In the enhancement MOSFET there are again two types, that is N channel and P channel. P channel, N channel and P channel. So difference is, if it is N channel, P substrate, if it is P channel, N substrate. So you can see the diagram here. Okay, these are the differences which you can notice. So working of E-MOSFET. By applying the voltage to the gate, charge carriers are introduced in the substrate that produces a channel for the conduction of current between the source and drain. N channel and P channel MOSFET has the same operation as the depletion type. The MOSFET except there is no channel to begin with. Instead, gate voltage is used to inject the charge carriers in the substrate to induce a channel between the source and drain. The gate is connected in forward bias to induce the charge carrier in the channel. Once the gate is induced, the current starts to flow between the source and the drain. These are the few differences between the depletion and enhancement MOSFET. In the depletion MOSFET, the type of MOSFET where the channel depletes with the gate voltage is known as depletion or DMOSFET. The channel is fabricated during the manufacturing. It conducts current between its source and drain where there is no gate voltage. Applying the reverse voltage to the gate reduces the channel width. Applying the forward voltage to the gate increases the channel width. It can work in both depletion and enhancement mode. It is normally a on transistor. It switches off with reverse biasing of gate. There is no threshold voltage for switching on the MOSFET. Diffusion or subthreshold current does not exist. So coming into enhancement MOSFET, the type of MOSFET where the channel is enhanced or induced during the gate voltage is known as enhancement MOSFET. There is no channel during its manufacturing. It does not conduct current when there is no gate voltage. Applying reverse voltage does not affect E-MOSFET since there is no channel. Applying forward voltage generates and increases the width of channel. It can only work in enhancement mode. It is normally off transistor. It switches on with the forward biasing of gate. There is a threshold voltage of which the MOSFET switch on. The E-MOSFET has sub-threshold current leakage between its source and drain. This is a diagram of P-channel E-type MOSFET. A P-channel enhancement type MOSFET is similar to N-channel except the voltage polarity and current direction are reversed. So even this is a enhancement type which is similar to N-channel except the voltage and current directions are reversed. Basic operation of E-type MOSFET. VGS is this operates in enhancement mode. So this is always positive. As VGS increases, ID will also increase. As VGS is kept constant, VDS is increased, ID saturation, and the saturation level and ID sat is reached. MOSFET symbol. So by this we will end up the module. So thank you.